Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone, welcome to physics session of 10 MCQs. Now today's topic is circular motion. So welcome to Bohdi Park NEET and J Academy. You can access various study material. For that you have to download the app. The link is given in the description. So let us start with first question. So in this first question, uniform circular motion, it is a theoretical question. In uniform circular motion, both velocity and acceleration are constant. So we know that in uniform circular motion, speed is constant and magnitude of velocity constant. But direction changes. At this point direction is tangential, at this point direction is tangential, at this point direction is tangential. Okay, so v vector is changing, so speed is constant but direction of velocity is changing. So we have velocity constant, so this is wrong. Velocity is not constant because direction is changing, and acceleration is towards center. So suppose this is acceleration, this is acceleration, this is acceleration. So acceleration is acting towards center. So direction of acceleration also changing. At this point direction is towards center, at this point this is the direction, at this point this is the direction. So direction of acceleration is not fixed. So first statement is wrong. In uniform circular motion, velocity and acceleration are not constant because direction is changing. Acceleration and speed are constant but velocity changes. Speed is constant, velocity is changing, acceleration also changing because direction is changing. So second statement also wrong. Both acceleration and velocity changes, so that is correct. Both acceleration and speed constant. Speed is constant but acceleration is not constant because direction is changing. So fourth statement wrong. Okay, so finish. Let's start next question. Now look at this question number 2. A body moved along x-axis and y-axis according to equation x is equal to 2 sin theta, y is equal to 3 cos theta. What is the trajectory? So we know that if we have x is equal to 2 sin theta, so sin theta is equal to x by 2, and y is equal to 3 cos theta, so cos theta is equal to y by 3. So sin square theta plus cos square theta is 1, so x square by 4 plus cos y square by 9 is equal to 1. So x by 2 whole square plus y by 3 whole square is equal to 1. So this is the equation of ellipse. Now the radius along x-axis is 2 meter and the radius along y-axis is 3 meter in the general form of ellipse. So along x-axis 2 meter, along y-axis 3 meter. So first option. Now next question. Third question. AR and AT represent radial and tangential accelerations. Then the motion of particle is uniformly circular. So for uniform circular motion, radial acceleration is centripetal acceleration, it is v square by r, and tangential acceleration at is equal to dv by dt. Now v is the speed. Speed is constant, so dv by dt is 0. So at is equal to 0 but ar is not equal to 0 because speed is non-zero, so v square by r is non-zero. So AR non-zero but AT 0. So third option. Next question. Now look at this next question. Fourth question. A particle is revolving in a circle with speed 20, radius 200. Its speed is increasing at the rate root 5. So dv by dt is given. dv by dt is root 5. V is 20. R is equal to 200. Everything is in SI unit. So we have to find acceleration. Now we know that there are two accelerations in uniform circular motion. One is AC, which is towards center, another is AT. So resultant we have to find. So this is the resultant. This is A net. So A net is equal to square root of AC square plus AT square. So this we have to find. Now AT is dV by dt. So that is root 5. So AT square is 5. Now AC is equal to V square by R. So 20 square by 200. So 400 by 200. So that is 2. So AC square is 4. So this is square root of 9, which is 3. So the resultant acceleration is 3 meter per second square. Okay, done. Now next question. Now look at this fifth question. A body moving in uniform circular motion with speed v, magnitude of change in velocity after it rotates by angle 120 degree. So this question is based on rotation of vector. If this is the initial vector and this is the final vector. So suppose initial vector is v I cap and final vector is also magnitude wise v, but it is rotated by theta degree anticlockwise. So initial vector v initial is equal to v I cap and v final is equal to, now we have to find the components. So this will be v cos theta I cap plus v sin theta j cap. Clear? So we have delta v vector is equal to v cos theta I cap plus v sin theta j cap minus v I cap. So using the diagram also we can understand. Suppose this is the circle. So suppose this is initial velocity at this point, and after some time this is the velocity. So angle by which it is rotated is theta. So this is x-axis, y-axis, this is 90 minus theta, this is theta, 90 minus theta, and this is theta. So this is the final velocity, this is initial velocity. So this is the change in velocity. So this is v cos theta minus v into I cap plus v sin theta into j cap. So find v common. So cos theta minus 1 square, which is cos square theta, plus this is magnitude of change in velocity. Okay, so v outside the root, then cos square theta plus 1 minus 2 cos theta plus sin square theta. So this is v square root 1 plus 1 minus 2 cos theta. So v square root 2 common 1 minus cos theta. 1 minus cos theta is equal to 2 sin square theta by 2. So that is equal to 2v sin theta by 2. So this is the formula, 2v sin theta by 2. So we have given theta is equal to 120 degree. So magnitude of change in velocity is 2v sin theta by 2. So this is 2v into sin 120 by 2. So sin 60, which is root 3 by 2. So v root 3. Answer is v root 3. So second option. So this is the formula, 2v sin theta by 2. Now finish. Now next question. Now look at the sixth question. A particle moving on a circle radius r, when particle moves from A to B, the angle covered is theta. The ratio of distance to that of magnitude of displacement. Okay, so we have to find distance by magnitude of displacement. It is covering an angle theta. So distance is equal to length of arc, and displacement is equal to the length of line joining initial and final point. This is the displacement. So this angle is theta. So we have this angle theta by 2, and this angle will be 90. So this length will be displacement by 2. So displacement by 2 will be equal to r sine theta by 2. So displacement is equal to 2r sine theta by 2. And the length of arc is equal to r theta. So r cancels. So theta by 2 sine theta by 2. So second option. Now done. Now next question. Now look at seventh question. A particle is moving with velocity, with speed v on a circle, radius r, centered at origin, as shown in anti-clockwise fashion. Average acceleration of particle during its motion from point A to point B. Now what is the formula for average acceleration? Average acceleration. What is the formula? This is delta v vector by delta t. Okay, change in velocity by time taken. Now it is going from A to B. So at A the velocity is vj cap. At B velocity will be minus vi cap. So change in velocity is minus vi cap minus vj cap. Now time taken, it is a quarter circle. So time taken will be t by 4. Speed is v. So we can find the time taken. Time period will be 2 pi r by v. So t by 4 is equal to 2 pi r by 4v. That means pi r by 2v. So substitute here. So you'll get average acceleration as, take minus v common. So minus 4 by t by 4, which is pi r by 2v, then into I plus j. So minus 8 v by pi r into I plus j. So actually this is v square. Yes, one more v is there. This v. So this will be v square over here. Okay, look at seventh question. We have at A the velocity is v j cap. At B velocity is minus v I cap. So average acceleration is equal to change in velocity by time taken. Average acceleration. Now final velocity is minus vi minus initial velocity is Vj, and time taken will be T by 4. Now T is equal to 2 pi r by V. So T by 4 is 2 pi r by 4V, which is pi r by 2V. So average acceleration is equal to minus V common into I plus j divided by T by 4, which is pi r by 2V. So this is minus V square into 2 by pi r into I plus j. So minus 2V square by pi r into I plus j. So second option. Done. Now next question. Now look at 8th question. We have velocity and acceleration vectors of a particle moving on a circle as shown. At an instant, the acceleration vector and velocity vector are given. So look at this circle. So at this position, this is the velocity, this is the center. So this will be the centripetal acceleration. AC, but the resultant acceleration is given like this. So in this direction. So we have tangential acceleration in this direction. This is AT. So if we consider the parallelogram, we get resultant acceleration. This is the resultant acceleration, A net. So that means AT is opposite to velocity. This is V vector and this is AT vector. So AT is opposite to velocity. So this is retardation. Speed is decreasing. When tangential acceleration is opposite to velocity vector, so speed decreasing. Okay. So speed must be decreasing. So first option correct. Now acceleration of a particle. So acceleration of a particle is a square root of AT square plus AC square. Now speed is decreasing, so AC is V square by R. So since speed is decreasing, so AC is also decreasing. And if we assume AT is constant, so we can say AC is decreasing, so A is also decreasing. Clear? So second is wrong. It is saying must be increasing, so that is wrong. Now dot product of velocity and acceleration. If you look at the angle between velocity and acceleration, this angle. So this angle is more than 90 degree. So the dot product A vector dot V vector will be negative, less than 0. Dot product is negative, so third option wrong. Magnitude of momentum. So magnitude of momentum is mass into magnitude of velocity. Magnitude of velocity is decreasing, so magnitude of momentum is also decreasing. So fourth option is also wrong. So our answer is first option. Done. Now next question. Ninth question. If a particle is moving in a circular orbit with constant speed, its velocity is variable. That's true because direction is changing. If its acceleration is also variable, this is also true because direction of acceleration is changing in uniform circular motion. We have already discussed. At this point, this is the direction of acceleration. At this point, this is the direction of acceleration. Okay. In uniform circular motion. Uniform circular motion. Angular momentum is constant. So angular momentum formula is mvr and it is axial vector. Its direction will be outward if it is anti-clockwise. and if it is clockwise, the direction will be inward. So if it is uniform circular motion, so direction of angular momentum is constant and speed is also constant, so magnitude also constant. So angular momentum is constant, so our answer is fourth option, all of these. Done. Now next question. Now look at this 10th question. In uniform circular motion, which of the following physical quantity remains constant? So uniform circular motion means speed remains constant, magnitude of velocity remains constant. So V vector magnitude is constant. Angular velocity is also constant. The direction of angular velocity, magnitude of angular velocity constant. Omega is equal to V by R. Angular speed is constant. Angular momentum also constant, because angular momentum is equal to mvr. So speed is constant and direction also constant. So L vector is constant. So all of these. Done.